Today in math, our I can statement is, I can read, analyze, and make inferences using data on a bar graph. A bar graph is a graphical display of data using bars of different heights. Here is an example of a bar graph. This graph displays the data of students' favorite sports. Imagine I just did a survey of my friends to find out what kind of movie they liked best. Here is a table of those results. Comedy 4, action 5, romance 6, drama 1, sci-fi 4. We can show that on a bar graph like this. A bar graph is a really good way to show relative sizes. We can see which types of movie are the most liked and which is the least liked at a glance. When looking at bar graphs, you can read, analyze, and make inferences. Reading graphs is taking information from a graph. For example, in this graph, I can see 4 people like comedy as their favorite type of movie. 5 people like action as their favorite type of movie. 5 falls between 4 and 6 on this graph. 6 people like romance as their favorite type of movie. It got the most votes. This bar is the highest. Only 1 person likes drama as their favorite type of movie. That bar falls between 0 and 2 on this graph. It got the fewest votes. That bar is the shortest. 4 people chose sci-fi as their favorite type of movie. Analyzing graphs is comparing information from a graph. For example, in this graph, 6 people chose romance as their favorite type of movie. 4 people chose sci-fi as their favorite type of movie. So 2 more people like romance than sci-fi. 6 minus 4 equals 2. Making inferences is figuring out what the graph tells us based on the data. If I wanted to invite my friends over for a movie, I can infer that they would prefer to watch a romance based on the data from this graph. Let's look at another example. Here, a survey of 145 people were asked, which is the nicest fruit? This table displays the results. Apple 35, orange 30, banana 10, kiwi 25, blueberry 40, grapes 5. In reading this graph, I can see that this group of people think blueberries are the nicest fruit. Grapes got the fewest number of votes as the nicest fruit. If I asked you to analyze this graph and tell me what the difference is in how many more people thought apple were the nicest fruit than how many people thought oranges were the nicest fruit, you would have to subtract 35 for apples minus 30 for oranges for a difference of 5. 5 more people thought apple were the nicest fruit than orange. Now, what if I asked you to tell me what the total number of votes for banana and kiwi? You'd have to add 10 for banana plus 25 for kiwi for a total of 35. Let's make an inference. If I wanted to invite my friends over for a snack, I can infer that if I wanted to choose 3 fruit, I should choose blueberry, apple, and orange because those are the top 3 fruits that my friends thought were the nicest. Let's look at one last graph. School lunch choices. Let's read the graph to start. 60 people chose pizza for lunch. 25 people chose corn dog for lunch because that bar falls between 20 and 30. 45 people chose burger for lunch because that bar falls between 40 and 50. And 30 people chose spaghetti for lunch. So let's analyze. How many more students chose pizza than burger as their school lunch choice? Well, 60 people chose pizza and 45 people chose burger. 60 minus 45 equals 15. So 15 more students chose pizza than burger as their school lunch choice. What is the difference of students that chose spaghetti and corn dog as their school lunch choice? 30 students chose spaghetti and 25 students chose corn dog. So we need to subtract 30 minus 25 equals 5. The difference of students that chose spaghetti and corn dog is 5. How many students chose corn dog and pizza altogether? In this question, I see altogether as a clue that I need to add. 25 students that chose corn dog plus 60 students that chose pizza is a total of 85. So altogether, pizza and corn dog altogether had 85 choices. I can infer that on pizza day, I'm going to get a lot of students choosing pizza for lunch. In this video, I showed you how to read, analyze, and make inferences using data on a bar graph.